Hi, this is Mr. Gallagher, and for this lesson, we'll be talking about piecewise functions. Piecewise functions at first can look intimidating if we think about the notation for them. Right here we have f of x equals x minus 2 if x is less than negative 1, and x plus 3 if x is greater than or equal to negative 1. And you can see down below is the graph that goes along with it. And sometimes they can even be a little bit more elaborate. As you see our second piecewise function, we have basically 3 lines of information which relates to the graph that's underneath. Now, instead of trying to think of it as one huge equation, sometimes it's easier to think of it as small parts. In fact, that's really why they have the name piecewise, because a piecewise function is just a function which is made up of 2 or more pieces. So we're going to look at a few examples, and I'm going to try to break them down into smaller parts so that we're not trying to do too much at any one time, and hopefully it'll be a little bit easier for you that way. So for our first example, it says graph the following piecewise function and then identify the domain and range. So the piecewise function that we have, f of x equals 2x minus 3 if x is less than or equal to 2, negative 1/3 x plus 1 if x is greater than 2. Well, whenever I deal with a piecewise function, the first part that I think is important to look at is actually the far right part where it talks about what x has to be. This information tells us where the break spot will happen in our graph. Basically, half of our graph is going to relate to the top part of our information, and the other half of our graph will relate to the bottom. You see, the top part depends on x being less than or equal to 2, and the top part greater than 2. Well, if we look at where 2 is on the x-axis, and if we cut our graph in half right at that spot, that's going to be where the 2 pieces come together for our function. So once we have the break drawn in on the graph with a dotted line, then we have to start looking at the 2 functions which make up the entire problem. So for the top part, 2x minus 3, the way you should think about that is as a line in slope-intercept form, y equals 2x minus 3. And since we've done graphing in the past, you know that that's a line that has a y-intercept of negative 3 and a slope of 2. So we can draw that line on our graph. And then the second part of the function, negative 1/3 x plus 1, well, if we think of that once again in slope-intercept form, y equals negative 1/3 x plus 1, and that's a line with a y-intercept of 1 and a slope of negative 1/3. We draw that in on our graph. So now what we have is a graph with 2 lines on it, but being that it's a piecewise function, we're really only focused on part of each of those lines. So we go back to our green box here on the right. For the top equation, the first line that we've graphed, it's only relevant when x is less than or equal to 2. So that would be to the left of our dotted break line. So we can eliminate the part of it that's on the right. If you were writing in pencil, you'd want to erase. And for our bottom equation, it's only relevant when x is greater than 2, and that's on the right of our break line, so we can erase everything that happens on the left. And the only thing that's left is to talk about what happens to the endpoints. So because our top equation, our first line that we graphed, says less than or equal to, that means that x can actually be equal to 2 at this spot. We're going to put a dot that's filled in, a circle that's filled in there to represent that 2 is a value that x could be on this line. And our bottom equation says greater than 2, meaning it'll never actually be equal to 2 on that line. So we'll put in a circle that's not filled in. And then the last part is to identify domain and range. Our picture is complete at this point, so now we just need to think, all right, so for the domain, how far to the left and right will my graph go? Well, you can see on the left side, It will continue on forever to the left. Even though it's going down, it's also going out to the left. And on the right, it'll continue on forever. So since it'll go in both directions forever and there are no gaps or breaks in the middle, domain is going to be all real numbers. Range deals with how far up and down our graph will go, and you can see clearly that both sides of the line will continue going down forever, but it does have a highest point that it reaches at +1. So since our y values will never go higher than 1, but it can be equal to 1, our range, all y such that y is less than or equal to 1. For our second example, we'll kind of be doing the opposite. In this example, we have the graph already created for us. Now it's up to us to figure out what the function will actually look like in its written form. So you can see we have our graph, and there's two lines on the graph. They make up the two pieces of our piecewise function. So you know your piecewise function is going to start with some kind of function notation. We'll start f of x equals, and then there's going to be two parts, basically one relating to each of the two lines. Well, just like with our last example, I'm going to begin by thinking about where the break happens. And you can see right here at this spot, that's where our left line ends and our right line begins. So if we count over, 1, 2, that spot is at 2 on the x-axis. So you know that 2 is going to be the important number that we're talking about. Now another important thing is which inequality symbols they're going to be. Since our line on the left has a circle that's not filled in, we know that that's going to only be a less than symbol. And then since our line on the top has a circle that is filled in, that'll be inclusive, so that'll have the greater than or equal symbol attached to it. So there's our line on the left, and there's the one for the right. Now we still didn't identify what the actual equations are that we're dealing with, so starting with this diagonal line, we have to think about a y-intercept. So it's -1, 2, 3, 4. So it has a y-intercept of -4, and then the slope, 1 over 1. So then the equation of that line would be y equals x minus 4. So you could think of it as y equals 1x minus 4, but you know, from examples in the past, we don't really have to write that number. So when we translate it into our piecewise function, x minus 4. Our second line, that's a horizontal line, so if you remember anything about horizontal lines, one important fact is that they have a slope of 0. So that really means we won't even see an x in our equation. And then we just have to think what the y-intercept would be if it extended all the way across. Well, that would go through at 1 on the y-axis. So then that would be an equation y equals 1. And then we write it in our piecewise function. We just have 1. And that's our final answer.